Topographic maps will tell you everything a normal map will tell you, the location of a road or the name of a lake, but topographic maps tell you so much more. They tell you the topography of the surface of the earth. They do that by means of little brown lines called contour lines, and they are lines of equal elevation. When you first look at a topographic map, it might look a little bit confusing. However, let's make sense out of this map of Mount Shasta. Here we have 3,000 meter mark. If a contour line is a line of equal elevation, I could walk around Mount Shasta sticking to this contour line, and I would never go up or down, but maintain the same elevation. When I'm done, I've come back to the same spot. That's always going to be true of contour lines. They will close to make a circle. The inside of the circle might contain the top of the mountain, and the outside of the circle will be lower land. Since Mount Shasta is a volcano, it's pretty symmetric, and you can see it looks like a bunch of bullseyes. But you have this funny little thing over here. If this line right here is 3,500, then this one must be higher. That means that this must be a high spot, but not as high as this one. If we take a look, we find that that's true. This is the top of Mount Shasta, or this is Shastina, a smaller mountain next to it. We can come up with our first rules of contour lines. Every point of a contour line has the same elevation. Contour lines separate uphill from downhill, and they always close to form circles. Well, always if you had a big enough map. This contour line over here on the right runs off the map, but if you had a bigger map, it would form a big circle. And the inside of the circle is always the higher elevation. Let's go to the East Fork of the San Gabriel River. Now, from this Google Earth map, it's really hard to figure out, is this and this the top of a ridge, or are those river valleys? Luckily, a topographic map should never be confusing. It makes it very clear what is up and down by telling you the elevation. Here we have a hill, and another hill. And between those hills, we have stream valleys. Notice that this area here along the East Fork doesn't have any contour lines in it, or very few, while this area here has a lot of contour lines. Why? I suspect you figured it out already, that the area along the San Gabriel River is flat, and the area along the mountain is steep. So that can be our fourth rule of contour lines, that contours are close together in steep terrain and far apart in flat areas. They're incredibly useful. If I wanted to plan a hike in the San Gabriel Mountains, I would choose the flat area. Notice that I've taken the 1,600-foot contour and made it bold here. As it goes along this river valley, where the stream is coming in, it must make a big detour up and around it. Now that detour is necessary in order to stay at the same elevation, because if you wanted to jump across the river, you would find yourself going down to the stream and back up again. You wouldn't be keeping the same elevation. Those detours can be found on all the contour lines, and that ends up being one of the rules, is that contour lines create a V pattern when they cross a stream valley, and the tip of the V's point uphill. So here's the tip of the V right there, and here's the tip of the V right here, and they're both pointing uphill. Water flows down, the V's point up. What if I wanted to hike from this spot here to this spot here? I would obviously be heading downhill. I'd be starting at 2,000 feet, 1,800 feet, 1,600 feet, and then I would cross the stream, go across this really flat area, and then I'd hit 1,600 feet again, start uphill, hit 1,800, and then finally back to 2,000. Notice that those 1,600s appear on either side of the stream valley. That's always going to happen. It happens as well if you go over a ridge. A ridge is just a long, skinny mountain. So if I start off at 1800 and head up, I'll next hit 2000. I go higher than 2000, but then come back down and hit 2000 again. Our sixth rule is that contour lines on opposite sides of a valley, here, or a ridge, here, always occur in pairs. Can you find anywhere on this map where two contour lines touch each other? How about two lines crossing each other? But you can't do it because there's a rule that says contour lines do not touch each other and they do not cross each other. However, what would they do with Half Dome in Yosemite National Park? You have a vertical cliff. That's the exception. The contour lines get so close together that they merge. So our rule that says contour lines don't touch or cross each other does have an exception, either at a vertical wall or at a cave. Here we have a spot in the northern San Fernando Valley. We have an 800-foot contour line, but this contour line has these little hatcher marks going inward. What is that about? Here's another one. Those little hatcher marks. There's a very nice clue here. These are gravel pits. They are closed depressions, and those hatcher marks point to the lowest spot inside. Now with a hill, the inside of a concentric circle is the highest point. But if you see those hatcher marks, like on this one, it's the center that's going to be lower. This gives us another rule, and that is that closed depressions, pits, have hatcher marks on the downhill side. What will this area look like on Google Earth? We have a pit here, we have another pit here, we have a hill, we've got a road, and that looks like an orchard there. Well, let's take a look at Google Earth. It looks really different. Wait a minute. What's different? Well, this road is gone. And that orchard there is totally gone. It's now part of the pit. And look at all the buildings that you see now. What has happened here is that the map is a bit out of date. You can find out the age of your map by looking in the lower left-hand corner, and it will tell you. Now, it's very unusual for the topography of the land to change, but it's not terribly unusual for us to put up roads and houses. So if you go out with your topographic map into the wild, you might find that it's no longer quite as wild as it looks on the map. But if you do go into some strange and foreign place, bring your map and know how to read it. You might think that it's a good idea to bring your GPS, and it is. But a GPS by itself isn't terribly useful. After all, you're middle of nowhere and you know your latitude and longitude. Unless you've got a map, that's not terribly helpful. And maybe you can get it to point to where your car is. But if there's a ravine between you and your car, and you have no way of knowing the best way around that ravine, you could be out of luck. If you want to explore strange and wonderful places, take a topographic map. If you've got a GPS, you can bring it along as well. And now, folks, go take a hike, would you?